Okay, now that we've taken a look at how the polyatomic ions change things for naming and making formulas of ionic compounds, we're going to take a look at what we call the transition metals. So the transition metals are located right here in the center of our periodic table. When you're looking at these, what do you notice? Hopefully, you take a look and you see that there are these extra numbers under here. Okay, so we're going to look at what makes these transition metals special and why they kind of throw a wrench in some of the things that we need to do. So transition metals can have multiple charges. That's what those numbers are. This has to do with the differing energy levels and how similar in energy that D sublevel is to the S sublevel of the next energy level. This means that there are multiple ways for those atoms to lose their electrons but still be stable. So if we think back to why atoms become ions is to try to make them more stable by either losing or gaining electrons. Notice that also that all of our transition metals are positive ions. So we can see these different charges under here. If we look at nickel, for example, nickel can have a +2, a +3, or a +4 charge. Okay, this is different than the ones we've been talking about up to this point, like this first column. They can only take on a +1 charge, or the second column can only take on a +2 charge. Notice too that there are some that don't have any charges listed. We're not going to use those, so you don't have to worry about them. How do we figure out the charge of a transition metal? So when we're looking at the name of something, we can figure out which one of those charges we're dealing with by looking at the name. There will be a Roman numeral in the name to determine the charge. So if we have iron with the Roman numeral 3 next to it, that means we have iron +3. If we have cobalt with the Roman numeral 2, we have cobalt +2. If we have manganese with the Roman numeral 4, that means we have Mn +4. Okay, most of the time, a little review of Roman numerals here. It's the number of tallies is the number that we have. So 1 would be 1 tally, 2 here is 2, 3 is 3. 4, then this V represents 5. So 4 is the V with a 1 on the left side of it, means it's 5 minus 1. So if we had a charge of 5, we'd just have that V there. Again, continuing this, how we figure out the charge of a transition metal. If we have the compound MnO2, okay, we first need to identify that this is a transition metal. And if we look up Mn on the periodic table, we'd see it's manganese. That, in fact, is a transition metal. It has the possibility of a +2, a +3, or a +4 charge. The step 2 then is to figure out what the overall charge coming from the negative is. So we have 2 oxygens according to our formula here. That 2 tells us that we have 2 oxygens. Each of the oxygens has a -2 charge. Just looking at the periodic table, we can figure that out. And then the 2 oxygens times our -2 means that we have an overall -4. Now our overall negative has to be the same as our overall positive. So that means that our positive has to be a +4. We need to figure out how many manganese that +4 is spread over. So because there's no subscript here, that means there's only one of them. So I'm going to take my +4, divide it by my 1 manganese, and get that the charge on each of those manganese is +4. Okay, so the step there is to divide the overall negative by the number of metal atoms you have. Okay, let's do another practice one. What is the name of the following? CuCl2. So step 1 is that Cu is copper. It has possible charges of +1 or +2. Step 2, chlorine has a -1 charge. We have 2 chlorines, so I take -1 times 2 and get an overall -2. My positive must equal my negative, so I have a +2. I have 1 copper atom. +2 divided by 1 means that that copper atom has a +2 charge. So the name here would be copper 2 chloride. If I look at nickel, Ni2S3, first I'm going to make sure I have a transition metal, Nickel is a transition metal. It has possible charges of +2, +3, or +4. To figure out which one, I'm going to look to sulfur. Sulfur has a -2 charge, but I have 3 sulfurs, so if I do the -2 charge on each sulfur times the 3, I get an overall -6 charge. We can see that right there. Then the positive must equal the negative, so I have a +6. That's spread over 2 nickel atoms, so +6 divided by 2 equals +3. So the name then would be nickel with the Roman numeral 3, so nickel 3 sulfide. Notice on both of these that I didn't do anything different with the anion. So these negative ions, I still changed the ending to IDE, just like we'd learned before. Now, challenge. We can combine this transition metal information with our polyatomics. So let's try these two out. Pause the video, try these out, see if you can figure them out. What is the formula for chromium 2 sulfate? And what is the name of Ti3PO34? Okay, hopefully you took a chance to pause the video and you're coming back to it now to see what the answer is. So we have Cr with a +2, we know that because of this Roman numeral 2. We have SO4, which has a -2 charge. That's sulfate coming off the polyatomic sheet. When we crisscross our charges or look at how they balance each other out, I get Cr2, SO4, 2. Because these subscripts are the same though, they balance each other, or they cancel each other out, so I can reduce to CrSO4. That also gets rid of our parentheses. Okay, so CrSO4 would be our answer there. For the name of Ti3PO34, Ti is titanium with possible charges +2, +3, or +4. PO3, oops, sorry, that should be a subscript. PO3 has a charge of -3. There are 4 PO3s, so I do my -3 times 4, and I get an overall -12. Because my negative must equal my positive, that means also I have a +12. I have 3 titaniums in my formula. That subscript 3 up there tells me I have 3 of them. So I take that +12, divide it by my 3, and I get a +4. So each titanium would have a +4 charge, which means I have titanium Roman numeral 4, so titanium 4 phosphate. Okay, go ahead and finish out these notes and then move on to your practice activities. Let your teacher know if you have any questions.